Hello everyone, welcome back to another video where we're going to be doing more Leetcode. We're going to be doing a Leetcode easy today. Replace elements with the greatest element on the right side. So let's read the problem. So we're given an array. Replace every element in that array with the greatest element among the elements to its right. Greatest element elements to its right, and replace the last element with -1. After doing so, return the array. So basically, for example, we'll look at this example here of the input. So input, it's an array of integers for each position I in this array. You need to replace array at I with the maximum element to its right. So let's run through this. For example, you see the output here. So 2, the first element, 2 here. What is the maximum element to its right? If you go through, it's 5. Out of everything, it's just 5. So you replace that position with 5. 4. Now let's go to 4. What's the greatest element to the right of 4? 5. So it's going to be 5 again. Now we get to 5. What is the greatest element to the right of 5? So now you have 3, 1, and 2. It would be 3. And then you go so on and so forth until you get to the last element, and you have to make the last element -1. Because there's nothing to the right of that last element. So it always becomes -1. So now let's look at the constraints here real quick. Read the constraints here. Right here. So basically this is what this is saying is array length can be up to 10,000. And the elements themselves, the numbers, integers, can be up to 100,000. So we need to make something efficient. We want something efficient here, ideally linear time, big O of n. So now let's think of the simplest way to do this, or what everyone first thinks of. So the most straightforward way to think about this is for each index I, here, look at all the elements to the right from I plus 1 to the end. So say we're on 2 here, right? Then just look at all the elements to the right and see what the greatest is, and then replace that element. That works, but that would be O of n squared, because that would require a nested loop, because for every index you would have to scan almost the whole array. So 2, you have to scan everything to the right, you get to 4, you have to scan everything again. So it would be O of n squared, n times n being the amount of elements in the input array. So if n was 10,000, this is too slow. So if you got this for an interview question, that would not work. So the key question is, can we reuse work instead of recomputing the maximum to the right for every position? Yes, we can. And that's exactly what the optimal solution does. So in our brute force, we went from left to right the traditional way. Why can't we go right to left? So because when you move from right to left, we already know the maximum of everything to the right. So obviously the maximum element we've seen so far to the right is the current index. So that's what we could do here. So if we maintain a running variable called right max, that will always store the maximum element we've seen to the right of the current index. So now let's write this in code here. Let's implement this so you guys can get a better understanding of what I'm saying. So now let's initialize the right max. As I said, the right max will initialize that to -1, because conceptually to the right of the last element, because remember we're starting from right to left, so we're starting at the last element. So conceptually to the right of the last element, where there's nothing right of the last element. Remember that. So the maximum should be -1. That's why we're starting with -1. So this value will be used as a replacement for the last element, and then updated as we move left in the array. So now we have the right max, and now we need to loop through the array in reverse order. So array -1 -1. So this loop goes from the last index down to 0, and then obviously the steps is just ones backwards. So that's what it means. So now inside the loop, we need to initialize a variable called new max. So new max is what the new right max should be for the next step. So this is setting up for the next iteration of the loop when we move left one position. So we just need to get the max. We use the max function here in Python, and then we do right max, the maximum from right max to right odd. So we're setting this up for the next iteration. So why does this work? So at index I, right max currently holds maximum amount of all elements strictly to the right of I. So array at I here is the current element itself. So if we move one step left, the max to the right of I -1 should include both the current element array at I and everything to its right, which is already summarized by the right max. So new max is the max of right max and array at I. So now the next line here, we have to replace. So now we're actually replacing the element at index I with our max, our right max. So this is the actual replacement required by the problem. So for position I, we set it to the maximum among all elements to its right, and that value is exactly right max. So notice the order here is important. So first we compute the new max using the original array at I, then we overwrite that position in the array with the right max. So then finally, we update the right max to equal the new max. So now we update the right max for the next loop iteration, which will move the one index to the left. So as we keep going, right max is always correct. It's the maximum of everything strictly to the right of the current index. So now when this loop is done, we should have an array with everything in the right order. So now we just return array, and then we should just be able to run this. Oh, what did I do wrong here? What did I just do wrong here? Oh, well, I put the for I in range. Yep, there you go.